Hey everyone, welcome back to MLWorks. In this video, we'll be continuing with our series on visual introduction to deep learning, and we'll primarily focus on deep learning foundations. So first we'll cover what is neural network architecture, and then we'll dive into the components of neural network. So what is neural network architecture? So we can segregate this neural network architecture into three main components. First is data, then task, then model. So data is nothing but where you have target and features and on which you will train your model on. And before we train, we want to understand the task. So based on the target that you have, whether it is a classification task or a regression task, that will decide. So once we have narrowed down on the data and the task, we'll start building our neural network architecture. So based on that kind of data you have, whether it is a text data or image data, the size of the neural network will differ. But irrespective of the data or the task, some things remain same, which is the prediction phase, and there is cost metrics, and then feedback phase, and then the adjustment of weights and bias. If you consider, if you are training a model, so you will send in your features along with your target. And what you will do is you will do some kind of matrix multiplication with weights. So once the matrix multiplication with weights is done, you will try to add some bias, and then you will try to compare it with ground truth, which is the target. The difference between the target and the predicted output is what is called as cost metrics. And if it is too huge, what we do is we calculate the gradient, and then we update the weights and bias. And then we again go ahead and predict on the same set of inputs, and we see whether the loss has been reduced or not, or cost has been reduced or not. So this is the basic flow of neural network architecture. So if you see here, during the prediction phase, we are going through forward pass, and in cost metrics, we see the difference between ground truth and the predicted output. And then during the feedback phase, we do back propagation where we update our weights. So this represents the adjustment of weights. Now let's talk about inner working of neural network. So the main component of neural network is neuron, which is the smallest unit and the key building block of neural network. So it takes in inputs and generates an output. So let's understand what are these inputs and what does neuron does and how it generates an output. So as I said, neuron is the smallest unit and building block of neural network. It takes in the inputs, performs some mathematical operations, and then it generates an output as a response. And what are these inputs and outputs? So these are just basic numbers. It could be positive or negative. And in this scenario where we have two inputs and one output. Now let's understand with an example. Before we get into the example, let's understand this general template of neural network. So consider, you have two features, x1 and x2, and we have corresponding weights w1 and w2. So what we do is we multiply these two and we multiply these two, x2 and w2. Then we add them together. And once you add it, we add a bias to this specific function, which generates us z, which is our weighted sum. So in short, what we have is z is equal to x1 w1, x1 into w1 plus x2 into w2 plus bias. Now if you see these weights and bias, these are adjustable parameters. So these are called as parameters in neural network, which gets updated as you are training. So what we do is we just multiply these two and combine them together, then add it with bias and generate our weighted sum. So as it mentioned here, weighted sum is nothing but neuron takes the input, multiplies it with corresponding weights, and all inputs are summed and a bias term is added to it. Now let's look at an example with values where you have input with value 3.0 and a weight of 0.5, then another input with 4.0 and a weight of 1.5. Now you multiply these two, you get 1.5, and you multiply these two, you get 6.0. Now you add both of these, you get 7.5. Then you add a bias, which is value 1, and then you get 8.5, which is your weighted sum. So once we calculate our weighted sum, then we pass our weighted sum to the activation function. So once we apply this activation function, we'll get some modification in terms of the final value that you get. But if you are applying a linear activation function, it will be same as your input. The output will be same as your input. Now, this is the part where you generate your final output in a neural network during a forward pass. Okay, so we are not done with the backward pass or the whole training process. We are just starting off now. Now let's talk about data. So without data, neural network won't work. So for data is to neural network has experiences to human. So without data, nothing works. So neural network tries to find the useful pattern and relationship within the data, and once we find those patterns or insights, we'll be updating our model parameters. So that is the flow that will keep happening in neural network as it tries to learn from the data, and it keeps updating its parameters unless it is able to do that specific task. So there are different types of data. First is structured data, which is normally our CSV file where you have features and target. Then there is semi-structured data like JSON, and there is unstructured data where you have text files or images or any other unstructured data like audio, video. So all these are different forms of unstructured data. Now let us talk about a dummy data set where you have a hotel room price prediction. So in this data set, distance and ratings is your features and price is your target. So we have a bunch of values here. Now as per our neural network understanding, so first once you get your features and target, then you have to do train and test split. So that's what we do here. So we'll be converting majority of our data will be taken as training data, and then rest of them will be taken as testing set or validation set. So that's what we do here. Now during the training phase, what will happen is we take the features along with your target, and then you pass that to your model, and this model will understand these features along with the target, and then it will create a model. Now once you have trained a model, it will be available for prediction. So what you do is you have your testing data set. So in that scenario, you don't send your target, you just send your features along with the model on top of the model, or send it to the model, and you predict your price. That's how you will be testing your model. Since if you remember here, what I've shown is you will have target in the testing data set, you will have target as well. So what you will do is you will send the features alone to the model and do the prediction. This is your prediction, and you will do this, take this prediction and compare with the ground truth. And once you see the difference between them is too huge, then you go ahead and update your parameters of your model. So this is the flow of neural network. Till now what we have seen is a bunch of topics. So we talked about neuron input output, how new input and neuron interact, that is the mathematical operation that happen between input and weights, and then we get a weighted sum, and then we talk about weights and bias, and then we talk about activation, then we talk about data and its types, and train and test split. So in the next video what we'll do is we'll be discussing about models, where we'll build a model from scratch with the same set of visualization, where we'll be updating the parameters and calculating the gradients. So we'll see you in the next video. Thank you for watching.